Okay, so as we're converting pounds here to kilograms, we've got two possible options. We picked the kilogram route, so we've canceled pounds. Now we're left in kilograms, which is not where we want to be. We want to be in grams. So in order to go from grams to kilograms, to kilograms to grams, kilograms has to go on the bottom, grams has to go on top. Do we agree with that part? Which of those is the larger unit? Kilograms. So kilograms gets the 1, and then we tell how many grams are in a kilogram. Flip that around. 1,000 grams, like 1 times 10 to the third. Okay, this comes directly from your metric system chart, right? 1,000 of the base are in a kilo. Okay, so here we did both types of conversions. This is one you need to memorize. Okay, you have got to know how many of the base are in a kilo, right? Kilo means 1,000. So 1 kilo is 1,000 of whatever base you're talking about, right? Okay. Good. Multiply across the whole top, divide by the whole bottom. The bottom was both 1s, right? So that doesn't make any difference to us. We're multiplying across the whole top, and we divide by 1, which, okay, we don't really need to do. Any questions there? Are we seeing the process of picking out your pathway and then plugging it into our T-chart first, right? You should go units first and then put in your numbers. Yeah. You're going to try the next two on your own. Inches to meters and centimeters to feet. So one's going US to metric, one's going metric to US. Okay, please, please, please raise your hand if you have any questions. Okay, did we match answers on both of those? Okay, and I gave you just both possible options for how to solve both of those. Okay? How many of you went 2 for 2 there? 2 correct answers. 0.1098 and 1.05. Raise your hand. Okay, if you didn't quite go 2 for 2, did you find where your mistake was? Very good. Purely metric system. Let's say I need to convert 3.2 4 centimeters to nanometers. Centimeters to nanometers. So before we get to it, get started on the T-chart itself, are those units bigger than, are those units both bigger than a meter? Are they both smaller than a meter? Is one bigger and one smaller? What do you think? They're both smaller than a meter. Okay, which makes it a little bit trickier, I think, when we're setting our table up. But there's no direct conversion to tell us how many nanometers are in a centimeter on your table, right? Would you agree with that? Look at your metric system table. There's no conversion that tells us how many nano is in a centa. So the pathway to get from centa to nano should be, what do you think? Centimeters to meters, then back to nanometers. Okay? So yeah, that's kind of the path you should follow. Do you think you can try this one on your own? Okay, go ahead and try it on your own. I'll give you a minute or two, and then I'll kind of start writing it out up here. Okay, I gave the answer here in both a regular version and a scientific notation. Right, we are gonna cover scientific notation in the next day or so. But either way of expressing this number, it's the same thing, right? This is the same as this, right? They both mean the same value. Is that what you had? Let's try, it's supposed to be in threes. 4.12 times 10 to the third micrograms to megagrams. Micrograms to megagrams. So 4.12 times 10 to the third micrograms to megagrams. Okay, so density. Have you heard of density as a property? We've talked a little bit about density, and we've given it as an example for an intensive property of matter. So remind me what an intensive property is. Yeah, color is an example of an intensive property. Kind of. Yeah, keep going. It does not depend on the amount of matter present. It does not depend on the amount of matter present. Okay? So the density of an object or a density of a substance is the same regardless of the size of the object. So if I have one molecule of it or if I have a million molecules of it, it has the same density. Okay? And so density is a little bit hard to describe in terms of what it is, right? But density has an equation that we use very often that helps us kind of determine what density is, right? And so the equation for density is mass divided by volume. So you'll see me write it like this more often. Density equals mass over volume. Okay, mass divided by volume. So, you'll see me use this equation a lot. This is an equation that you need to have written down. If you don't have it memorized, you should have it memorized probably. So highlight it, circle it, do something that you need to find it in your notes quickly. But we will use density pretty often. So essentially what you're measuring here is mass, right? The density of something is how much it weighs, right? What is its mass divided by how much space it takes up. Okay? So if something is really, really heavy but doesn't take up a lot of space, that means it's a really dense object. But if something doesn't weigh that much and it does take up a lot of space, like air, right, or oxygen, gases, right, things like that, they don't weigh that much, but they take up a lot of space, they're going to have a really small density. Okay, so what essentially density is measuring is how compact your matter is. Okay, how compacted it is. Right? If it's really heavy but it doesn't take up much space, that means it's very dense. If it's really not heavy and yet it does take up a lot of space, that means it's not so dense, right? It's not very compact. So if something is dense, the atoms are more compact, which means they're closer together, right? They're heavier. If something's not very dense, the atoms are farther from each other. So the kind of standard by which we measure density is with water. Does anyone know the density of water? Water has a density of 1 gram per milliliter. And so that's the standard kind of at which things are measured. Will it float or will it sink? Right, so water has a density of 1. That means 1 gram of water takes up 1 milliliter of space, or 1 cubic centimeter of space. Okay, so you might want to write that down also. Density of water equals 1. Okay, and if I know the equation for density equals mass divided by volume, mass is usually measured in grams, and volume is usually measured in milliliters. Usually, right? And grams is a little g. Right? So the units for density are usually grams per milliliter. Okay, you could also scale it up to say kilograms per liter. You can kind of put it anywhere in between as long as it's a mass unit divided by a volume unit. Right? Most of the time it's going to be grams per milliliter. Right, so how many grams does it take? How many grams does it weigh divided by how many milliliters it takes up? That same amount of substance. Okay? That's what we're looking at for density. Okay, determine the density of an object that weighs 16 grams and has a volume of 35.35 centimeters cubed. Do you remember what I told you about centimeters cubed last time? Or cubic centimeters? Right, cc's, we talked about cc's. So what do I know as cubic centimeters equal to? Milliliters. Cubic centimeters and milliliters are the same thing. So cubic centimeters is also a volume unit that you could use in your density problem. Okay? So I know 16 grams is going to be my mass. So my mass equals 16 grams. My volume equals 0.350 centimeters cubed. And I'm trying to solve for density. So as we start working these problems, I'm going to make a list, just like this, of my variables. Okay, how did I know that this was my mass variable? How did I know that 16 grams was my mass variable? Right, it says weighs, and the unit grams needs to be an indicator for us that that's talking about mass. Okay, centimeters cubed should be an indicator to us that we're talking about volume. Okay, when we see a cube like this, does that have anything to do with the number itself? No. The cubed has to do with the unit only, right? Because to find the volume of something, I'm taking length times width times height. That's how you find the volume, right? Would you agree with that? Volume of a cube? Yes? We've taken geometry? Okay. Length times width times height is volume of a cube. So that's how I get my centimeters cubed. Okay? It has nothing to do with the number itself. The number itself has nothing to do with that cube export. Okay, so to find density now, I'm going to take mass divided by volume. And I should be getting a big number here or a small number? Divided by 0.35 means we're going to end up with a pretty big, a bigger number. Let's say bigger than 1, right? So bigger than density of water. And I got 45.71 grams per cubic centimeter. Right, that's my final answer there. Right now I'm not worried about how many decimal places you round to. Right? I usually like 2 decimal places. We are going to learn about how we choose the number of decimal places to round to here in the next couple days. But for right now, that's what I got. Okay, would you agree with that? Okay, the units are grams per centimeter cubed. Why
do you have like a...
Okay, so as we're reading through this problem, we need to start identifying our variables. Identifying variables. So, if my unit is grams per milliliter, what do we know that has to be? What variable is that? That is my density, right? 3.21 grams per milliliter. And it says it has a density of that. Okay? If I have 24.8 grams of my substance, what variable is that going to be for me? Mass or volume? Mass. Right, 24.8 grams. And that means I'm solving for volume, right? So I always put a question mark by what I'm solving for. Okay. So now I'm going to plug it into my equation. 3.21 equals 24.8 divided by volume. Okay, so here I have a variable on the bottom or in the denominator of my problem. What do I need to do to get it by itself? What do I need to do to solve for V here? Right, I need to multiply it by V on both sides. Are we on the same page here so far? Then to get V by itself, what would I do? Good. Divide 3.21 on both sides. So it ends up looking like this. Volume equals 24.8 divided by 3.21. Okay? So if you take a look at our first problem, we have volume here and 3.21 here. All we're doing is switching these two places. Right? When we're solving for volume, when in the denominator, all we're going to do is switch those two places. Okay, which is exactly what we did here. Okay, so to solve for volume, I'm taking 24.8 divided by 3.21. And we get somewhere about 7.73. What would my units be here for volume? Milliliters, right? When we solve density problems, our units have to be really consistent. So since my density was measured in grams divided by milliliters, that means my mass has to be measured in grams and my volume has to be measured in milliliters. Okay? If my mass was not given in grams, I would have needed to convert it to grams. So you have to pay really careful attention to that. Okay? Whatever your density is measured in, your units for mass and volume have to match that. Okay? So grams divided by milliliters, that means those are what our mass and our volume need to be measured in. Okay? Try this one on your own, the second one. If I have 0.32 liters of a substance with a density of 2.19 grams per milliliter, what is the mass of my substance? We should see something that's jumping out to us here. All right, I have 0.32 liters of a substance with a density of 2.19 grams per milliliter. So I know my density equals 2.19. I know I'm solving for mass. So that has to be my question mark. That means the other thing left over is volume. Okay, some of us had trouble picking out volume based on its units. So volume units are liters or milliliters or centimeters cubed, right? Those are all volume units. So when in doubt, right, find what you're solving for, give that your question mark, and then your other one has to be the leftover. Here's the problem. My density unit is grams per milliliter, which means my volume needs to be measured in what? Milliliters, right? This guy needs to be measured in milliliters, and right now it's in liters. So I need to convert that, okay? So I'm going to take 0.32 liters, I'm going to go from liters to milliliters, okay? And I need to give liters the 1, because that's the larger unit. How many milli are in a liter? 1,000. So I multiply that out, and I get 320 milliliters. Okay, are we on the same page with that part? Most people, I felt like, were getting that at least, right? 320 milliliters. Now I can start plugging it in because my units match. Okay? So I'm going to say 2.19 is my density equals mass divided by volume. Okay, you can keep your units there, right? It's probably a good idea to keep our units there. But now if I want to get M by itself, what do I need to do to both sides? Multiply by 320 milliliters. Okay, so now M is by itself in the numerator. That's what we want, right? So we stop right there and we say 320 times 2.19, and I get mass equal to 700.8. What would my units be here? Grams. Okay.